Today we're going to cover section 3.2, applying properties of rational exponents. So please find page number 10 in your notes and we'll get started. First, a quick recap on exponent laws. If we have x to the n times x to the m, if we have x to the n divided by x to the m, if we have x to the n all to the mth power, and then if I have x over y all to the nth power, go ahead and quickly pause, come back, and fill in what each of these exponent laws are. All right, so you should have filled these in. These are not new. So when we multiply, we add our exponents. When we have a power to a power, we multiply the exponents. And then when we divide, we subtract the exponents. And here, x cannot equal 0 because we can't divide by 0. Same thing with this one, y cannot equal 0. Here, the n on the outside belongs to both the numerator and the denominator of the fraction. All right, and so as we go into this, you'll see why the warm-up that you were assigned today pairs with this. All right, so if you haven't done the warm-up yet for today, go back, do that, upload it to Classroom so that you get credit, and then we'll go from there. So let's look at this. All right, so using properties of rational exponents to simplify the expression. First, we see, yes, we have the same base of 7, all right? And then we are multiplying, which means that we're adding our exponents. So I have 7 to the 1/4 plus 1/2. So over off to the side, you have 1/4 plus 1/2. Go ahead and do that arithmetic, work it out. Yes, you need a common denominator. And so you should end up with 1/4 plus 2/4, so 3/4, which means this becomes 7 to the 3/4 power. All right, so again, it's nothing new. It's just that we're now using our exponent laws with fractional exponents. Now let's look at the next example. So with this one, we have 6 and 4, so those are different bases, so we cannot combine them, and they're both being raised to the second power. So that's going to become 6 to the 1/2 times 2 times 4 to the 1/3 times 2. If you want to do the multiplication off to the side, that is fine. 1/2 times 2 is 1, so I have 6 to the first power times 4. 1/3 times 2 is 2/3. If you don't know or understand operations with fractions, please find time to see me later this week or find a video on YouTube. And we can write this as 6 times 4 to the 2/3 power. Again, make sure that your exponents look like exponents and not like mixed numbers. I don't want to see 4 2/3. That is not the same thing as 4 to the 2/3 power. All right, now let's look at the next one. So again, this is thinking back, right? When we have negative exponents, if you need to make yourself a small note, x to the n power equals 1 over x to the negative nth power, 1 over x to the nth. So here, I'm first going to rewrite this so that now I have over 4 to the 5th times 3 to the 5th to the positive 1/5 power. I can't combine the 4 and the 3 because they do not have the same base. That is equal to 1 over 4 to the 5th times 1/5 times 3 to the 5th times 1/5. And 5 times 1/5 is 1. So that becomes 1 over 4 times 3, 1 over 12. If you need to at any point in time, pause, rewatch, rewind if you don't follow any of this. All right. So now let's go ahead and continue. All right. So we can now look at this division problem. So the exponent understood to be on this 5 is a 1. And we're dividing, so we're going to subtract our exponents. 1 minus 1/3 is, again, you can do that off to the side, 1 minus 1/3, 1 over 1, get a common denominator, all right, becomes 5 to the 2/3 power. All right, now let's look at this last one. Here, what I want you to notice is that the 42 is being raised to the 1/3 power, and the 6 is also being raised to the 1/3 power. So we're first going to rewrite this as 42 over 6 all to the 1/3 power all to the second power. Because the 1/3 here belongs to both the 42 and the 6, just like it's written in the original. So now I can simplify. 42 divided by 6 is 7 to the 1/3 to the second power. And then when I have a power to a power, I'm multiplying 7 to the 1/3 times 2. And so here I end up with 7 to the 2/3 power. All right, so now there's one small typo in the column on the right. Go ahead and fix this. This should be 5 to the 1/3 power, not 1/2. Fix that. Pause the video, work out these 4 problems using the notes that we just took, and then come back to check your work. All right, so you should have just worked those out. Go ahead, pause the video, check, make sure that you understand and got the same answers, and then we'll continue on to some more examples. So looking at the next page, we're gonna zoom in here, pause and copy this, and then come back. So at this point, you should have copied our property product of radicals. So what this means is here, our index is n of a times b. We can separate out the index to write it as the nth root of a times the nth root of b. Same thing with division. If I have the nth root of a fraction, I can rewrite it as the nth root of the numerator over the nth root of the denominator, as long as, again, the denominator is not equal to 0, because we cannot divide by 0. So let's use this to simplify some of our roots. Looking at example 3. So first, I have the cubed root of 12 times the cubed root of 18. Because their indexes are the same, I can now rewrite this as the cubed root of 12 times 18. I think it is easiest for us not to multiply 12 and 18 and get a big number, but to find the prime factorization of 12 and 18. So go ahead and make a factor tree for each of these. So like 12 is 4 times 3. Actually, you know, we could do it that way, but I think it's going to be better organized if we do it a little bit differently. 2 factors of 12 are 4 and 3. 2 factors of 4 are 2 and 2. So 2 times 2 times 3 is equal to 12. This is the prime factorization of 12. Now please find the prime factorization of 18, which is going to be 2 times 3 times 3. All right, so now I can rewrite this as the cubed root. Instead of 12, I'm going to use the prime factorization. 2 times 2 times 3. Instead of 18, I'm going to use the prime factorization of 18. Times 2 times 3 times 3. Now I'm going to rewrite these in exponent form. So I still have the cubed root of, I have 2 to the 3rd power, and then I have 3 times 3 to the 3rd power. Well, the cubed root of 2 to the 3rd power is 2, and the cubed root of 3 to the 3rd power is 3, and so I end up with 2 times 3, which is 6. Okay, so here we found the prime factorization so that we could easily take the cubed root. Now let's look at the next example. Here again, right, we have the same index of 4, all right, and we're going to now combine it as the 4th root of 80 over 5. Because 80 is divisible by 5, right, so when we divide 80 by 5, we end up with the 4th root of 16, and 16 is equal to 2 to the 4th power, which means the 4th root of 2 to the 4th power is 2. So that's how we should go about simplifying these. Now let's go ahead and look at the next two. Go ahead and try this one on your own right now, and then come back and we'll go over it. So first, you should notice they have the same index. So we can write it as the cubed root of 32 divided by 4. And 32 divided by 4 is 8, and the cubed root of 8 is 2, because 2 times 2 times 2 is 8. So that is our answer. The next one, hopefully you notice, hey, these indexes are not the same. The 81 has an index of 4, the 27 has an index of 3. So 81 is equal to 9 times 9, which means that it's equal to 3 times 3 times 3 times 3, right? Those 3's are for this 9, and then these 3's are for the second 9. So 3 to the 4th power is 81. So I now have the 4th root of 3 to the 4th over the cubed root of 27, hopefully you know off the top of your head, is 3. And the 4th root of 3 to the 4th is 3. And so 3 divided by 3 is 1. So that is how we do this one. All right, now let's continue. We'll go over these other two examples here next class. So on to, actually we're going to skip page 12 and we're going to move on to page number 13. So now we just did multiplying and dividing. Now we're doing adding and subtracting like radicals. So here, the question you have to ask yourself is, 1, do we have the same index? Here, yes, the index is both 4. The second question that you need to ask is, do we have the same radicand? Remember, the radicand is the number inside of the root. Yes, we do. So 1 4th root of 10 plus 7 4th root of 10 is 8 4th root of 10. Now go ahead and, what if I had 2 5th root of 11 plus 12 5th root of 11? We have the same index of 5, we have the same radicand, so they are like radicals and we can combine them. So 2 plus 12 gets me 14 5th root of 11. So the index and the radicand do not change, just the coefficients change when we do this. Now let's look at example 5. Here are the bases the same. So 1, do we have the same base? Yes, we do. They're both 8s. And 2, do we have the same exponent? Yes, we do. They're both 1/5. So that means that 2 8 to the 1/5 plus 10 8 to the 1/5 is 12 8 to the 1/5. All right, the way that we add these is really similar to, like, if I had a 12x squared minus 3x squared, and I simplify that to get 9x squared. The x squared didn't change, right? It's just the number of them that changed. So now let's look at how this next example is different. Again, so here we're looking, 1, we need the same index. So we have that. Yes, but we don't yet have the same radicand. So we are going to simplify our cubed root of 54. So what is a perfect cube that is a factor of 54? So like 54 is divisible by 2. 2 times 27, okay, is 54. The cubed root of 27 is 3. So I get 3 cubed root of 2. So now I can come back over here and I can take out my cubed root of 54 and replace it with 3 cubed root of 2, because those are equivalent, minus the cubed root of 2. Now we have the same index and we have the same radicand. And 3 cubed root of 2 minus 1, if it's helpful for you to put the 1 here, you can, cubed root of 2, leaves us with 2 cubed root of 2. So we're simplifying the root in order to have the same radicand. Once we have the same radicand with the same index, we can combine our like terms. So why don't you now try the next problem, and then you can come back to check your work. So with this one, we have the same index. Great. We don't have the same radicand. So I have the 4th root of, actually, I'll simplify that off to the side. The 4th root of 32. Well, 32 is equal to 16 times 2. 16, the 4th root of 16 is 2. So I have 2 4th root of 2 plus 6 4th root of 2, which leaves us with 8 4th root of 2. Remember, the index and the radicand do not change. Let's look at the next one. Here I have the square root of 8. you know, hopefully by now, that the square root of 8 is equal to 2 root 2. So this leaves us with 2 root 2x, because the x we can't take the square root of, plus 3 root 2x. We have the same index of 2, that's understood to be there, and we have the same radicand of 2x. So we end up with 5 root 2x when we combine like terms. All right, so the major takeaway with these is that we need to simplify the radicand so that they're the same before we add or subtract them to combine. Now go ahead and complete extra practice example 5. Pause, work through them, and then come back to check your work. All right, so at this point, you should have paused and checked your work. Actually, if you didn't do this one, that's okay, but you should have done the rest of them, so you can check those. All right, so pause, check them, look at the work, see if you have any questions, and then we'll continue. Anything you have a question on, star or circle so that we know to go over that next class. Now let's continue. This next page is blank, and then we are on to our last couple of examples. So example 6, simplifying expressions involving variables. So simplify the expression. So what I think is the most helpful is to first separate this. So we're going to write this as the cubed root of 64 times the cubed root of y to the 6th power. The cubed root of 64 is 4 times, now we're going to convert to exponent form. So this is going to become y to the 6 over 3 because the index becomes the denominator of the fraction. So this turns into 4 times y squared. 6 divided by 3 is 2, which is 4y squared. And that's how we're going to go about simplifying these. So now let's look at example 6. So this one's a little bit different. Here, we're in exponent form. So first, that 1/3 belongs to everything. So I'm going to rewrite this as 27 to the 1/3 power times p to the 3 times 1/3, because when we have a power to a power, we multiply our exponents, times q to the 12 times 1/3 power. Now I'm going to convert my 27 to radical form, which means that's going to become the cubed root of 27. And I'm going to now simplify my exponents. So 3 times 1/3 is just 1, so p to the 1, times q, 12 times 1/3 is really the same thing as 12 divided by 3, which is 4. And now I can simplify the cubed root of 27 to 3, p q to the 4th power. So the major takeaway with these is that we're separating out, right? Like here, I separated into the cubed root of each one, and then for the exponents, we're going to use for the variables, we're going to use exponent form. For the numbers, the coefficients, we're going to use radical form to simplify them. We will do some more practice on this next class. Please upload a copy of your notes to Classroom to earn credit for today's classwork assignment, and I will see you next